Hello everyone, we've got a Christmas styled question. David, who's putting up some faulty lights on his Christmas tree, and there's 3 different coloured lights on this set of lights. We've got a red light which is flashing every 7 minutes, we've got a green light which is flashing every 8 minutes, and an orange light which flashes every 9 minutes. Now, this person, David, he turns the lights on at 9 o'clock in the morning, and in doing so, all 3 lights flash at the same time. We need to figure out the next time that all 3 lights will flash at the same time. Okay, so whenever you have problems or questions where things are coinciding or happening at the same time, they are highly likely to be problems on LCM, right? Which is what we have here. If you have problems where things need to be divided or shared, they tend to be questions based around the highest common factor. Saying that, so I've got to work out the lowest common multiple of 7, 8, and 9. Remember, the lowest common multiple means the smallest number that appears in the 7, the 8, and the 9 times table for this particular case. Also remember that every integer greater than 1 is either a prime number itself or can be written as a product of prime numbers. So what I'm going to start by doing is, I'm going to start by drawing a factor tree for some of the numbers. I don't need to do one for 7 because 7 is a prime number, right? But if I do it for 8 and 9, so we'll start with 8. Think of a factor pair of 8. Well, you can have 2 and 4. 2 is a prime number, so I'd put a circle around that. 4 is not. That can be broken down into 2 and 2. Right? Underneath my factor trees, I like to write down the decomposition. So it's 2 times 2 times 2, and we'll write it in index form as 2 cubed. Now, if I do the same for 9, 9 is the same as 3 multiplied by 3. They're both, 3 is a prime number, so I can put circles around there. Right? So 9 I can write as 3 times 3, and in the index form as 3 squared. Now, remember, we also have 7 over here, right? One way you can work out the lowest common multiple is by drawing a Venn diagram. I'm not going to do that for this particular problem, right? Because an easier way that you can work out the lowest common multiple is if you've written your decomposition down in index form, you can look at each prime number in turn and take the highest power and multiply them together. So I'm going to rewrite 7 in the following way. As 7 multiplied by 2 to the power 0 multiplied by 3 to the power 0. Right? And the reason I'm doing that is because in my other lists, the prime numbers that I have are 2 and 3. And also remember that any base raised to the power 0 is 1. So this is really the same as 7 times 1 times 1, which is 7. Similarly, for 8, I'm going to rewrite that as 7 to the power 0 multiplied by 3 to the power 0. Right? Again, I have 7 and 3 in my other lists. And for 9, I'm going to rewrite that as 3 to the power 2 multiplied by 2 to the power 0 multiplied by 7 to the power 0. Remember, these are equal to 1. All right? So, now that I have that, I can work out my LCM as follows. So look at each list and look for the highest power. So the highest power that I have for 2, well, that's 2 to the power 0 in that list, that's 2 to the power 0 in that list, that's 2 to the power 3 in this list. So I want to have a 2 to the power 3. What about 3? Which list contains the highest power of 3? Well, it's obviously 9, right? So I'm going to multiply by 3 to the power 2. And which list contains the highest power of 7? Well, it's obviously 7. So I'm going to multiply that by 7. This ends up being 8 times 9 times 7, right? Which is 504. That means that the next time the lights go off together is 504 minutes after they first went off. Now, they were plugged in at 9 a.m., right? So they all flashed together. We were asked what time will they all flash together. So I need to convert this 504 minutes into hours and minutes. So if I write, let's just put my units in. Remember that there are 60 minutes in an hour, so I want to divide this by 60, right? So 504 divided by 60. I could just do some short division or long division to work out what that gives me, but always have a look and see if you can simplify your fraction first, make your number smaller. I can divide both numbers by 12, right? So if I put across through that and write divide by 12, put across through that and write divide by 12, I end up with 42 all divided by 5, right? And you can check that if you want by doing some short division or long division. Now, I am actually going to do some short division because I want to convert this into whole hours. I want to know how many whole hours I have. Remember, your divisor goes outside. Okay, so 5 goes into 4 0 times, right? Carry the 4. 5 goes into 42 8 times with a remainder of 2. That means 504 minutes is 8 whole hours and 2/5 of an hour, right? So I need to convert that 2/5 of an hour. Remember that there are 60 minutes in an hour, so you want to do 2/5 multiplied by 60, right? Have a look and see if you can cross cancel. I can, so divide that by 5, divide that by 5, right? And we end up with 60 divided by 5 is 12, 2 times 12, 24, right? So in other words, 504 minutes is the same as 8 hours and 24 minutes. Now, given that the lights were plugged in at 9 a.m. and that's when they first flashed together, the next time that the lights will flash together is at 5:24 p.m.
Thanks for watching this video. Click on one of these boxes to watch another maths problem being solved. If you have an upcoming GCSE maths exam, we're running a course in the February half term. Link in description.